Hello everyone and welcome to the first video on our game. For now at least, it's called Project Candle Quest and is developed in RPG 025. In this first video, I'd like to share some of the progress we've been making on the fundamental systems of the project, as well as explain what our project is about. Everything you're about to see is likely very early stages and subject to change. Project Candle Quest could be defined as a story-driven puzzle game much like the Portal series. The story as of writing this is still a little bit vague and needs to be fully developed, but it is specific enough already to define the game from start to finish in terms of gameplay and scenery. Originally, we set out to develop a 2D pixel art game with a rather different premise, but we shifted to low poly, custom painted 3D very early on. We are not done exploring this art style fully yet, but we think that it holds a lot of potential for our game. Once we think we have something in that area that is good enough to show, we will try to make a video about it in the future. Since we set out to develop a rather calm experience, therefore specifically not a shooter, we settled on puzzle mechanics as the primary game mechanic. I wanted to use light and perspective as puzzle mechanics first, but one of our team's members suggested using light rays or something similar with optical devices such as convex or concave lenses, mirrors, various different light sources and dispersion prisms. The player would then be tasked, similar to the Portal series design philosophy, to position an array of given devices in the level in a way that demonstrates the player's understanding and knowledge of these devices while posing a challenge. Combine this with various receivers that might only accept light of a specific color, and we believe that one receives a set of mechanics that can compose interesting problems to solve with lots of room to think out of the box in terms of level design. On screen you can observe some very early test levels demonstrating working convex lenses with a rudimentary laser pointer as a light source. Unsurprisingly, designing puzzles for puzzle mechanics that, at least from our research, aren't used to this extent in other games is a fairly difficult process, and we are still trying to figure out what works and what doesn't. This phase of development is thus highly experimental, of course. We have done some playtesting already with some of these absolutely minimum complexity and easy puzzles and learned quite a few things from that. For example, that the lenses should be semi-transparent to give the player more feedback on its behavior. One playtester thought the convex lenses only worked at the edge because its effects were occluded on screen by the lens itself if the player shot the light through or close to the middle. We didn't have too many playtesters playing these levels, so most conclusions about playtime and the amount of fun had are a bit unfounded, but our tests we did perform suggested that players that took longer to solve these puzzles reported more enjoyment out of the process. If not coincidental, we think that this indicates that the most boring puzzles imaginable, with the most unfinished and rough visuals and audio presentation, is fun to play around with. That would be a very good sign from the get-go, but we obviously require more testing in the future. Now you may be asking, what is RPG even? RPG, or Uchronia Project Blender Game Engine, is a standalone branch of Blender's 2.79's game engine. For our purposes, RPG 025 shall be sufficient, especially since I'm already quite familiar with it. Although we are looking forward to the release of the range engine that brings more features to RPG 025 as a potential alternative. My current focus lies in implementing the various different optical devices listed before. This is actually a very interesting task, since it requires some physics and a lot of linear algebra. Since I could not find any vector-based descriptions of the behavior of optical lenses, I had to come up with a method of calculating them myself. If you would like to skip this part where I will be explaining my math and code, here's your timestamp. Now, the way this works is actually very interesting. From my research about lenses, light rays that hit a lens parallel to each other share the same focus point. Also, if a light ray hits the lens in its center, it will pass through unaffected. From that information, we can process a light ray that hits a lens defined by its direction vector and a hit point. If you assume that the given light ray hits a convex lens in its center, we can simply add its direction vector to the lens position. This means that we assume for a moment that the ray hits the lens perfectly center. If we normalize the direction vector beforehand and multiply it with a given focal length in meters, we get the exact position of the focal point of this light ray, because light rays that hit in the center are unaffected by the lens. We compute the vector between the hit point and the previously calculated focal point and receive the outgoing vector of this light ray. Concave lenses do the same to calculate the focal point. From that, they negate the focal point vector and calculate the vector between the negated focal point vector and the lens hit position to calculate the outgoing vector. Mirrors are fairly simple. Now, since RPG provides a solid math library that takes care of creating these matrices, these processes are actually not that complicated to implement. In contrast, creating a system that allows light rays to be created, processed by optical devices, and shot again in its new direction by the device is not exactly a trivial task. The rays we trace are calculated by RPG's physics engine, thus everything that is supposed to interact with these rays somehow is active on a particular physics layer reserved for these processes alone. A laser pointer, for example, calls the shoot ray function of the ray controller empty present in each scene, while providing the necessary information such as a direction vector, a light origin, and color every logic tick. The controller then shoots a raycast with the given information using RPG's physics engine on a reserved physics layer, stopping at any object with the parameter optical object, and reporting the hit position in a reference to the optical object. The controller calls the give trace function of this object, providing the hit point, color and the direction vector. Then this object processes this information as described above and calls the shoot ray function of the controller again. Thus, every light's path is traced and for now trivially drawn on screen by the controller, every logic trick. This system still contains some unwanted behavior and bugs and is not final. And most interestingly, this isn't even as performance expensive as one might think, but I will have to investigate this topic further. As I continue to implement new mechanics and test out different ideas with playtesters, our artist is creating artwork and designing the world around the puzzles. In our next video, we hope to show you some of the assets and level designs that show our early experiments with our art style. If you have a history of designing puzzles in, say, one of the Portal games and are interested in our game, you are invited to contact me about potentially getting involved. If you enjoyed the video and want to support our project, you are of course invited to subscribe to my channel, rate the video and join my Discord server where we can be reached. Thank you very much for watching.